Hey everyone, in this video I'm going to show you how to do a few problems where you're finding the average rate of change from a graph in Delta Math. Okay, so average rate of change is, before I read the problem, average rate of change is very similar to the idea of slope, which you're already familiar with. When we find the slope of a line, we always do the rise over the run. And average change actually works, average rate of change works the same way. It's just that our graph is not going to always be a straight line. So average rate of change allows us to find the average rate on any kind of graph. It could be curved. It doesn't have to be a straight line, but it's still the same idea that we use with slope, where we find the change in y and divide by the change in x. So each of these problems has multiple parts, which is why it says at the bottom, you must answer all questions above in order to submit. And I'll show you what the first step is. So it says the function y equals f of x is graphed below. Plot a line segment connecting the points on f where x equals -2 and x equals 6. Use the line segment to determine the average rate of change of the function f of x on the interval -2 is less than or equal to x is less than or equal to 6. So I know this is a lot of words and variables and numbers. Don't let it stress you out. Just listen to my steps. So the first step, it says, is to plot a line segment. We need to connect the points on this function where x is -2 and x is 6. So I'm going to start by going on my graph to where x is -2. This is not where I'm going to plot my point right here, because this is -2, but on the x-axis. I need to go to where on my graph I have x equal to -2. So I go to where x is -2, but then I see that my actual curve is above the x-axis. So I go up to the point on my curve at x equals -2. So again, it's really important that you go to the point on the curve where x is equal to each of these values. So now that I've clicked here, I'm going to drag and plot my other point where x equals 6. It says to go where to x equals -2 and x equals 6 in the problem. So again, I'm going to go over to where x is +6, but this is not where my curve is at x equals 6. This is just the x-axis. So I see that my curve is below. So I go down to the curve, but I need to make sure I'm staying lined up where x equals 6, and I click on the point on the curve where x equals +6. So now I have my dotted line, my line segment, that's going to help me find the average rate of change. So now to find the average rate of change, if you look below the graph, we need to find the change in y. This triangle means change in y, and then the change in x, okay? And then we're going to divide those two numbers to get the average rate of change. So something that's really important, we're going to start with finding the change in y. Always start with the green point on the farthest to the left. Always start there. And then I'm either going to have to go up or down for my change in y, because we know we can either rise up or rise down when we have a negative change. So I can see that I'm going to have to count down to get to my other point. So I am going to definitely have a negative change in y. I'm just going to put the negative there so I remember that. I'm going down here, so I'm definitely going to have a negative change in y. Another thing that's important to look at for these problems is that sometimes the y-axis isn't counting by ones. The x-axis is always counting by ones here, but sometimes the y-axis isn't. I see it's going 2, 4, 6, 8, 10, 12, so I can tell it's counting by 2. So when I'm counting from my left point to my right point, going down, I'm going to make sure I count by 2s to match up with the y-axis. So I'm going to start with this point on the left, and I'm going to count down, straight down, until I'm lined up with my other point. So I'm going down 2, 4. So each time I count down, I'm going to count by 2. So let me start again. 2, 4, 6, 8, 10, 12, 14, 16. So now I'm lined up with my other point, and I counted down 16. So my change in y is a -16. Now I'm going to go to just where I just counted to. I'm going to stay down here, and I need to count left to right, okay, to figure out my change in x. So 1, 2, 3, 4, 5, 6, 7, 8. So my change in x is 8, and then my last step for the average rate of change is just to divide the change in y by the change in x. So -16 divided by 8, you can do it in a calculator if you need to, but it gives you -2, okay? So I'm still going to do one or two more problems. So this next one says the function is graphed below. Plot a line segment connecting the points on f where x equals 0 and x equals 1. Use the line segment to determine the average rate of change on the function on the interval from 0 to 1. So again, my first step, I need to find the point on my graph at x equals 0 and the point on my graph at x equals 1. So x equals 0 is right here in the middle of the graph, but I need to go to the point on my curve at x equals 0. So my curve is above, so this is the point on my curve where x equals 0. So I'll put my first point there, and then my second point is going to be at x equals 1, okay? But again, down here, I'm not on my curve, so I need to go to where on my curve am I at x equals 1. So that's right here. So now I've plotted my line segment, and I need to use it to determine the average rate of change. So I'm going to do my change in y and then my change in x, and then I'm going to divide them. So again, I always start with the point on the left and count to the point on the right. So I'm going to count my change in y first. Now first let me see, my y-axis is going 5, 10, 15, 20, 25, 30. So that means it's counting by 5. So every grid line that I count down is going to be counting by 5s. And I see that I'm going to have to go down to go from the left point to the right point. So my change in y is definitely going to be negative. So I'm going to count down by 5s until I'm in line with the point on the right. So 5, 10, 15. Now I'm in line with this point, so I had to go down 15. So my change in y is negative 15. Now I go to where I left off and I need to count my change in x. My x-axis is counting by 1s, so I count from left to right as far as I need to go to reach my next point. I count 1, and there I am. I'm already at the next green point. So my change in x was just a positive 1. Now my average rate of change, I divide y by x, negative 15 divided by 1. If you need to do it in a calculator, you can, but that's just going to give you negative 15. All right, let's see if we can do one more. So this function, it's asking us to find the average rate of change from x equals 6 to x equals 7. I really want to do one where it is increasing. Okay, let's do this one. This one's asking from x equals negative 7 to x equals 3. So I'm going to go on my graph to x equals negative 7, but I need to go to the curve at x equals negative 7. So that's this point right here. And then x equals 3. Look at this one. At x equals 3, my graph actually is touching the x-axis right here. So I am going to plot my point right on the x-axis because that's where the curve is touching at x equals 3. Now I need to find my change in y and my change in x. So let's look, my y-axis is counting by 2, 4, 6, 8, 10 by 2s. So to go from my left point to my right point, I'm going to count up until this time I have to count up. So I'm going to have a positive change in y. So I'm going to count up until I'm in line with my point on the right. And again, I'm counting by 2s this time. So I'm going to count up 2, and then I'm already in line with my point. I only had to go up one grid line, which counts as 2. So my change in y is a positive 2. And then my change in x, I'm going to count left to right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My change in x is 10, and now I just have to divide 2 divided by 10. I think we can just leave it as a fraction. Yep, we can. So if you get a fraction, you can just leave it 2 divided by 10, or you can simplify it to 1 over 5. Okay? All right, and that's all.